Brown corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text, totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying Sentence Tokenizer, the resulting output shows all individual words, tokens. Stop word removal. Let's import the stop word library. From nltk.corpus, import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. Combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From nltk.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lematizer from nltk.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization.